Hello and welcome to another video. In this video we're going to be working on house robber 4, and in this one there's several houses along a street, and there's houses the same as like the other house robbers where you can't steal from adjacent homes, but now this is kind of weirdly worded. So capacity of a robber is the maximum amount of money he steals from one of the houses. So essentially the robber is going to steal from a bunch of houses, and then the amount he's going to steal is the maximum of any one of those. So you're given integers nums, and you have to rob at least k houses, and you want to return the minimum that the robber can rob, given that the robber robs at least k houses. And so it's like the minimum maximum the robber can rob. So you're going to rob some houses, and then you're going to return what's the minimum maximum you can rob. So in this example, you have to rob 2 houses, so you're just going to rob like this, and then the minimum maximum is going to be 5. Because you have to either rob the 5 and the 9, the 5 is less, so it's going to be 5. And then here, looks like the minimum maximum is 2, so you can rob like this. Yeah. So this problem's kind of tricky, because first you think like you might be able to do some DP or something, but house robber DP, your states would be something like index, and then like how many you've left, which is k. And that would be n squared, so that wouldn't work. So instead, I was doing this problem and I was kind of thinking like, how can I do it? And also because we've been doing so many binary searches, I was trying to figure out a way how to do it with binary search. Essentially with binary search, if we can somehow figure out, like, given a total, can we make the maximum less than or equal to that total, right? And then we can just try every number from 1 to, like, what's the biggest maximum we can have? It would just be the maximum of nums. And then whatever is like the one we can, the smallest number that works here is the one that's going to work. And so for this part, if you have an array of a bunch of houses, like let's take this example, let's just take some array, whatever. There's another kind of intuition you need. So you need the binary search, then there's another one, and then after that the problem's easy, but both of these together aren't super easy to figure out. Okay, so let's say these are the houses. So let's say we're trying to rob like a maximum of 4. So how do we figure this out? Like basically we're trying to ask, like, given this array, is it possible to rob, let's say k is like 4 as well. So k is 4. Can we rob, so the maximum is 4 or less, and we rob 4 houses. So how do we determine, like, do we do another DP or what is it? So it turns out here you just want to be greedy, because if a house is available, you always just want to rob that house, because we're trying to just maximize the count of houses robbed. So like if a house is available, it's never going to be better to rob the house after, because if we rob this, then we have to skip this. But then we can rob the next one, where if we rob this, then we have to skip this. So no matter what, like, if we rob this, this is all available to rob, and we robbed 1. But if we rob this, then this is all available to rob, and we robbed 1. So we always have more options as being greedy here. So then it becomes kind of an easy problem. We just basically say, like, okay, if a house is, you know, whatever we're trying to get or less, we'll just rob that. So like we'll skip this, we'll rob this. So that's 1 house robbed. Then we have to skip this because we just robbed 1. Can't rob this, can't rob, can't rob. We'll rob this as well, so that's 2. Skip this, and we rob this is 3. And so we weren't able to rob 4 here. And then that's basically it. So we just make this function that just greedily counts how many houses we rob. We check, did we get k? And if we got k, then we can say that this is a valid minimum, and we just try to minimize that. So that's basically the problem. Yeah, so let's code that. So I'm going to have a helper function. It's going to return a boolean, and it can be like can rob. We'll give it nums. We'll give it k, and we'll give it carmin or something, or like target. So let's write this first. So basically all we have to do is just, if a house is available, we'll try to rob, and then we'll increment the index by 2. If it's not available, we'll increment the index by 1. So we can say int count will be 0, and I equals 0. So while I is less than length nums, we're going to try to rob. So if nums I is less than or equal to target, because we can't rob any house that's bigger than the target. So if this is available, then we'll increase the index, and we will also increase the count. And regardless of no matter what, we'll just increase the index here. So if we did rob, we'll increase by 2. If we didn't, we'll increase by 1. And then we just need to return that the count of the houses we robbed is greater than or equal to k, right? We have to rob at least k. If we're able to rob k, this is good. Okay, so now we just do the binary search. So we'll go int left equals. So the minimum money is 0. The maximum money is going to be the maximum of the nums. So we can calculate that on the fly, I guess. So, or we'll just loop through nums and get it. So for nums r equals, yeah, it's right and num. Okay, so we got both of those now. And then we're going to have a result, and we'll say our result will start off as the right. So and I like using this binary search template. I think it's really good. You just maintain a result variable. So it is an extra variable, but then you never have to worry about like, what do I have to do? Do I return left or right? It's always the same. So I prefer this a lot. So then we just have the normal template of left equals less than or equal to right always. And we're going to calculate a pivot, which is left plus right minus left over 2. And then we're going to say if can rob this pivot value, then we're going to set our result equal to it. And this is always the template. So if this is a possible correct value, we'll set our result equal to it. And then we want to think like, where do we want to go? So we just want to try smaller numbers. So then we'll just do this. So if we wanted to go at the max, we would do the same thing, except we would go bigger here. But yeah, so then we just have this, and we just return a result. All right, let's give that a go. Okay. Oh, this actually needs to be equals pivot, this one. Okay. Oh yeah, we need to give all those other things. So nums, okay. All right. Okay. Yeah, so it becomes really tricky to try to think of like a DP way to do this, but once you realize like we're just looking for the same kind of thing. We're looking for a min or a max binary search. Like that's literally the pattern. Because if we know one min works, then we know every min above that works, and if we know one min doesn't work, then we know every min above that doesn't work. So yeah. So this is going to be so essentially we're looping through num, so that's n. And then the other number is going to be like the max of n or whatever it is. Or this will be a log of that. Okay. All right. And then, yeah, that's that. And space. So we didn't make anything, I think, right? Left, right, that's it. Yeah. So definitely was kind of a hint that we've been doing binary search every day. So yeah. And I think reasonably tricky problem, because A, you have to figure out the binary search, and B, you have to figure out how you want to rob the houses, that it's just greedy, or you just always want to rob the first one first. It's always going to be the best. Yeah, and not try to do some weird DP thing. But yeah, it's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.